The interesting piece here is that it's even not often required to get out of like the specification of the cell manufacturers, because there is already so much optimization possible within those windows, which are not used currently. So I think that's like one is really like the pressure on the cell manufacturers. I think they are just too dominant and they are too much into scale. They don't care about it, and they ship it, take it or leave it. And then the asset owner integrators have to live with it. But there is already like a lot of like optimization potential within those windows. And then there are like additional concepts. So to provide additionally longer performance guarantees for batteries by really like the monitoring piece, but also on the other hand, having an additional partner which can take some risk like insurance companies.
Hello everybody, welcome back for another installment of Transmission. In today's episode, Quentin is joined by Stephan Rohr, founder and co-CEO of TWAICE. If you're enjoying the podcast, please consider hitting like and subscribe. It really helps us reach a wider audience. And with that, let's jump in.
Stephan, thank you very much for coming and joining us on the podcast. If during this podcast you can hear, well, it's Thanksgiving, right? We're recording on Thanksgiving. So if you can hear loads of noise downstairs, that is an amazing Thanksgiving dinner being put together by my wife and toddler. So just the first one is a disclaimer. There's lots of noise and banging downstairs. It's all going to be worth it for me anyway.
Thanks for having me. And like, unfortunately, I'm not at your place, right? Joining the Thanksgiving party.
And you guys, we're going to talk all about the business in a second, but you guys, you're set up in Chicago, right? You got an office in Chicago, you got people there, and you've got a pretty big presence in the US now. What's Chicago like?
So yeah, I mean, like we originated in Germany, in Munich, but really covering whole Europe. And since 1.5 years, also like operating in the US market. And like our office, our core team is in Chicago based. But we also have people like in Florida, Texas now, so really covering especially your energy storage market heavily in the US. I think 2 years back, it's not like a secret, right? The Inflation Reduction Act changed things heavily. So like following the investments in the energy storage space. So that's also like why we started really investing heavily in the US market, and we'll continue that next year as well.
And let's talk about TWAICE. You guys have been doing this for quite a while now. And it's a really interesting space, which is looking at physically how batteries are performing. Not what we do, which is just talk about how much money they're making or what they're doing in the markets. You guys are looking at the engineering side. Do you want to just talk for a second about the company, your journey, what you do there, what the vision is, all the good stuff?
Yeah. So yeah, absolutely. So we started more or less like 10 years back. I started into the battery space in 2013, 14. I started with my PhD, and like there was like a large battery research grant from where like Germany tried to build up like battery research in Germany. And what we created in 2014 is like the first 200 kilowatt hour energy storage. It was like one container. And you can imagine like during that time, we call it grid storage. Now it's like more like 200 megawatts hours. So very tiny one. And it was called Energy Neighbor, and we did research how different like grid services, CNI services, like how they're impacting the storage around lifetime, about health, about safety, and really did research about how can we improve like the energy storage asset in 2014. And then like we just continued our research, and in 2017, 18, so we did that at the TU Munich. I and my co-founder, we realized that there was not really like a battery analytics provider out there in the market. So who really as a third party provides analytics software to like energy storage companies, but also electric vehicle companies. And there were some companies out there which built their energy storage or built the electric vehicles, maybe some kind of like in-house developments, but not like a third party provider. And that is actually what we went after in 2018, really like founding TWAICE to provide analytics software to, on the one hand side, really de-risk the storages, de-risk the assets, because as the whole market is scaling up, there's like a lot more on safety, on availability, on health. which you need to solve to really make more money also from you guys flowing into the assets. And secondly, also like this whole industry is still very nascent, right? So you have to create tools and processes and also services to really optimize it, right? So you bring an energy storage live with like whatever frequency service, and then a couple of years down the road, it's changing to some other operating modes. How does this impact lifetime? What do you have to expect from the technical asset? So this is like things we help to discover. And so that is what we started in 2018. And yeah, then we kicked it off and really tried to unlock the ramp up the battery industry with our analytics services. And the good thing was in 2018 is that we were really like the first mover in that space of battery analytics, because the people we approached during that time were more focused, do energy storage really make sense, or electric vehicles really make sense? And we were already part of like, how can we optimize it? So it was early, it was nascent, but also this first mover helped us to really build a significant team and get really like a big significant support from investors and to get there where we are right now.
And so the company is roughly 10 years old, you say. And how can we put some figures on it? How big is the company? I mean, I must say, you guys have raised a lot of money, right? You raised 70 million euros or maybe even more than that. So you've got a lot of firepower to build something really big. Yeah. How big is the company and how big is the vision?
So, I mean, like we started in 2014 with like our PhDs and then really created the company around 5.5 years back in 2018. So the company is really 5.5 years old, but we are of course working on this topic for around 10 years now. And so we are currently a team of around 135 people and growing. So I would say really like the most significant team on battery analytics you will find in Europe and in the US market. And we raised like $75 million so far. And it's really there because I think they're like, when the industry is scaling, you need to really provide professional commercial software to the industry, right? And we, from the beginning, were really focused on building a partner, a professional partner for the long term and for scale. Because when you look at energy storage assets, they will be live 10, 15, 20 years. And no one wants to see like your analytic provider going out of the market 2-3 years from now. So really building it for the long run was always very important for us from the beginning. And then you just always like underestimate how much effort it is to build like commercial battery analytics software. You need to have like a lot of PhDs and a lot of like data scientists and software engineers to really merging it together and provide proper commercial software, which you can integrate, which is usable, which draws the inside out of the assets. You have to take a lot of different cell chemistries, all those kind of areas need to like really require a massive investment. And then additionally, a lot of our customers, and touched on that at the beginning, are not only like in Europe, but also like the US market. So you have to go also like global or like international very fast. So this, of course, also requires investment and upfront investment. And so that is what we did the last 5.5 years now.
And in the research, before we had this conversation, I was doing some research on you guys and what you've been up to. And what's evident is we're very privileged in that a lot of your customers are also our customers. And what we're noticing is that, as with any technology adoption curve, as the technology matures, it moves from being a speed and cost of capital play into something a bit more sophisticated. And I think really the winners in the world of anything to do with batteries, I think the winners really are starting to differentiate based on data and being an informed operator and, optimizing the resources they already have rather than the cost of deploying more resources. I think that's kind of, it happens, happening in wind, happening in solar, happening in all sorts of things. But it's really exciting because there are a lot of different ways to use, particularly in battery cells, there's a lot of different ways to use different types of data to have I'm not going to say competitive advantage, that's a bit strong, but to increase ROI. So you guys are based in Munich. Are you talking to me right now from Munich?
So like I'm talking to you, yes, from Munich.
And so the company's roughly five years old. You've raised a load of money. You're doing all this battery analytics stuff. You've got PhDs, data scientists. You've got physical assets. You're doing tests. You're doing, the scientific method, if you like, at this stuff. What's the value prop? What do you guys do for customers? Why do they come to use you guys?
So I think I really would connect it to your like statement before. I think that what happens now, what happened with wind and solar, and now also like translating to energy storage, is that first of all, everyone wants to, and that's a bit different with energy storage than it is with wind and solar. First of all, they also want to have a safe operation. So they really want to make sure that the energy storage is safe, which they are deploying and operate safely. So really de-risking it, really helping them understand when there are certain things coming up in the future which impact the safety of their storages. And the second thing is, and that is actually playing very much into what you have mentioned, is we call it availability. So when you look at, and you also Modo published things on that, is helping the asset owners, utility companies, but also integrators in the energy storage market to really increase the availability of their energy storage assets. Why? Because as the more energy storage assets are getting deployed, people realize that maybe the storages are on, but not always available and partially available. And that creates, and this directly cuts into their profits, into their profitabilities, right? And so really helping them to de-risk the assets with safety, but on the other hand, really helping them to increase availability of their assets. So that is what we are doing. And maybe just from a logic, how we do that is we really connect to the energy storage assets. So we take data from the energy storage assets. It's like from the SCADA system, EMS, battery management system. So the data which gets pulled out from the energy storage assets. And we process those kind of data to draw insights out of it, which then helps the asset owners or utility companies to replace certain components or to improve the balancing mechanism. So really helping them to get actionable insights out of their assets based on the data which they already have in the assets.
For you guys, who is the customer? Because there's a lot of people involved in the value chain, right? So, of course, in this conversation, we're going to talk about grid scale batteries. But you guys, you look at electric vehicles, buses. There's a load of stuff. Maybe we'll touch on that later. But let's just think about grid scale batteries. You mentioned a point there about availability. You guys will know that in the US, especially in Texas, availability matters a lot more than European markets because there are so few days where you make so much money. And I completely get it there. But is the customer the asset owner, or is it the cell manufacturers? Is it Samsung SDI or CATL? Is it the cell manufacturer, or is it the asset owner, or is it the bank, or is it the O&M provider? Who uses you guys?
So in grid scale energy storage, which is one major market area for us, it's either the integrator, so who builds the assets like the OEM, or the asset owner / IPP / utility company.
So there's a lot of acronyms in here. A lot of acronyms. So let's go to the first one. So an integrator. Can you give some examples? What kind of company is an integrator?
Fluence, for example.
Fluence, okay.
Then you have the asset owners, which are which owns and operates the assets. The second piece, it's for example, M&A, Goldman Sachs in the US market, who builds up these storages and operates them. And then there is also utility companies, of course, involved because they're a bit different than the asset owners. But of course, they also now growing their contribution in energy storage assets and own them. And for both parties, for the integrators and for the asset owners and utility companies, we provide this analytics suite to de-risk the storage assets, but also help them to improve availability. And I think the thing is when you look at, for example, availability, it's important for both sides. Because the asset owner and utility companies, they exactly how I described it, right? So you have certain hours a month where you make your monthly revenues, right? For example, or certain days where you make your yearly revenues. So the storage has to be 100% live and not partially available. So really discovering that early, replacing things also already when you in the commissioning phase. So that's crucial. And then on the other hand, it's also the integrators, of course, need to solve those issues. So their O&M teams, they have maintenance cycles. So they have to get smart around when do they schedule in those replacements. They have to get proactive, right? Because customers, they don't want to see their systems not available when the peak is coming, right? So really helping also the integrators to get smart in terms of make the track less rolling, but also getting more proactive to their customers on those topics. And also I think everyone acknowledges in the whole industry that grid scale are still not no-touch systems. So they are still touchy systems. You have to still keep a lot of doing on the maintenance side. and helping them to improve that is also crucial. But at the end, it's all about like de-risking it and increasing, for example, availability topics. And this affects both parties. So it's not what you have mentioned, the cell manufacturer. It's really like those two parties which are crucial for us.
And I've got to ask the question. So how does it actually work? What do you guys, and talk to me like I'm a 5-year-old. What do you guys actually do? So I get the idea, right? Where you get loads of data from a load of batteries and you put it all together and you do AI and whatever, and you figure out how to schedule maintenance and when to replace cells. And that is really valuable to folks who own batteries. I get that. But in the detail, how does it actually work? You know, what data do you pull? How do you pull that data? Are you allowed to? Do the cell manufacturers even give you the data that you need? Do you have to do some kind of working around the edges? Does it affect warranties? How do you do what you do?
So very good question. So in general, when you look, for example, at energy storage assets, they get like constructed, commissioned, implemented, and then go live into like the operational mode. And usually we come in at TWAICE at this early phase. So when like the integrator and or EPC companies like really constructing the sites, putting the storage asset there and going through the first commissioning phase and then entering into the operational phase. And that is usually how we onboard our analytics, which means it's connected to their like SCADA system or like their data transfer system, like EMS. And it also mostly contains the information which the battery management system provides. So every battery has like a battery management system which gets the temperature, current, voltage data. So more or less the stupid battery data, temperature, current, voltage, and transfer that to like the EMS and to like some SCADA systems and getting it over. And this is actually where we onboard like our analytics, and then we can provide insights already in the commissioning phase and in the operational phase. And to give you some example, right, to what it basically is, right? So when we get the data, for example, in the commissioning phase, you can detect with our systems if, for example, like you have this large containers of a lot of battery modules, racks, cells in those containers, and you need to detect, for example, if they all contact the right way. So they all, of course, like you have a connector from cells to a module, and from module to one rack, and from a rack, and they're all connected. And what you can see already is that, of course, due to quality issues, for example, they are not all connected the same way. And this automatically connect your system. We process the data, we clean it, the data, we get rid of like anomalies and those kind of things. Then we apply our algorithms and models to it. And then you can exactly see, for example, that certain modules in this container are not right connected. And then they even can see that with thermal cameras afterwards when they go into the container and see that it, for example, generates more heat. And then they identify certain modules through our software, which they can replace before the storage goes live. When they would not do that, they will see it maybe like in 6, 12, 18 months. And this exactly causes, for example, availability issues.
So wouldn't the equipment manufacturer, so say you bought a system from Fluence or Tesla or whatever, wouldn't the equipment manufacturer do that themselves? So you guys are representing the asset owner in this, and so the asset owner can do their own checks without the conflict of interest, let's say, of if you're a supplier and you're also checking your own homework.
Yeah, so I think it's a very fair comment. So I think in general, both parties are interested, right? So because like when you in this phase of this handover and this commissioning phase, it's actually beneficial for both parties to identify issues as early as possible. Why so? Because it's for like the asset owner. I mean, they invested millions, hundreds of millions in those assets. They really want to make sure that they get what they bought. But also the integrators, for them, it's like the best period to exchange things because it's cheap. The truck is already rolling to the sites. They don't have any like annoying customers because like the storage are not available or they have some challenges afterwards. So it's a beneficial phase for both parties. And what we do is we help the integrators on the one hand side, but we also help the asset owners to understand the assets into detail. And then either like both parties or one party draws a conclusion out of it. But it's actually a quite important phase and beneficial phase for both parties to get the transparency around it. And there are a lot of examples where you can draw the insights out of the data, and then it's onboarded, and then it's really like about the continuous monitoring of those systems. That's the second phase.
Well, I was going to ask you about that. So we just talked about essentially site acceptance testing. You could actually do it at the factory too, couldn't you? And then you could determine what the difference was between in delivery and transit. But so you do site acceptance testing through data, and that's great. And then you get the seal of approval. I guess you do offer that, a seal of approval, a stamp saying, yes, this is okay. And then it moves to the operational phase. How about the ongoing phase? What does the data tell you there?
So, I mean, at the ongoing phase, it's the similar thing. First of all, like all storages are like batteries. So like they have like electrochemical batteries and they are degrading. So they lose performance over time or like lose capacity over time. So first of all, it's really helping like the asset owners or also integrators to understand how batteries are degrading over time. And that highly impacts on how you operate them, like which kind of grid services is it like more like whatever frequency control, or is it more like more intraday trading, whatever impacts, and where you place the storages and which kind of HVAC system, so cooling system is applied, impacts highly the degradation. So helping them to understand how the assets are degrading and also helping them to optimize it, right? So for example, have to lift the HVAC system a bit and get less degradation out of your system. Or on the other hand side, for example, so that's one, like it's the health and degradation part of it. Secondly, safety monitoring. So even if you have checked it and approved and accepted, right, there are always like trends, anomalies popping up in these like large container parks, which are unforeseen, right? And to really monitor that and make that predictive to see really like when certain trends in certain cells and modules are really like behaving abnormal and really surfacing that up. That's the crucial piece as well. So really ensure the safe operation. But then the third thing is really coming back to the availability topic is there are a lot of things now when you see in the market, a lot of like the assets which are now currently deployed are LFP systems, for example, like massively more and more. And there you in general always have the challenge of like proper SOC calculation, which impacts everyone in the market, and really like identify
just on that. So are you saying it's more difficult to calculate state of charge or state of health on a LFP type of cell rather than an NMC?
100%. So when you look at SOC estimation, and usually state of health estimation is based on SOC. So you first of all have to do the SOC estimation, and it's a way more complicated with LFP systems than it is with NMC. Why is that? It's more technical, but it's like you have this, it's called open circuit voltage. So it's like this curve, how the battery is like discharging. And the thing is with LFP, it's so flat. So even if you're like, if 50% SOC or 55% SOC, the voltage are not really different. And that's a challenge. So, and then you like measure the system and you see it's like you're 3.5 voltage or 3.5 voltage, but it can be like 50 or, so it's really hard to detect. And
measurement error. There's a physical measurement error issue.
And then now the tricky part comes in. This curve is changing over lifetime. So most of the manufacturers have put in like a standard like table initially, but the thing is it's changing over lifetime. So it makes it more off over years. And that is really, which has created a lot of challenges.
And it's totally the reason why it's, you have an old iPhone and you're like, hold on, it says I've got 100% battery. And of course, it only lasts 2 hours. We're not necessarily talking about LFP there, but it's the same principle, right? Which is if your lookup table, if you like, for your converting measurements into actual usable numbers like SOC, SOH is static, then you've got a problem.
100%. And look, I mean, I come just from a customer meeting like 2 weeks back, and they had like it's a 400 megawatt hour system, so quite large one. But he said like we have 0% SOC, and I pull another 50 megawatt hours out of the system the next couple of hours.
Wow. So isn't that dangerous, Stephan? Isn't that so? Can you just talk a little bit? We're going well off piste here, but I think our listeners are they're pretty technical. They know their stuff. So let's do it. So can you just talk a little bit about, there's this idea that you have to keep battery cells between 5% and 95%, or 10% and 90%, or 20% and 80%. There's a band, right? For lithium-ion battery cells, there's a band where you want to keep state of charge between those numbers. And if you go outside of that, then lots of problems happen. Could you just talk a little bit about what that is, why it's there, and how significant you think it is? Because for some of our listeners who own and operate grid-scale storage, they may be operating to quite restrictive bands. And they may be wondering, if I could really just open this up a little bit more, or give my trader or optimizer a bit more capability, what could we do? And is it worth the risk? So could you just talk about that for a minute?
Yes, absolutely. So I would even separate this question in two parts, right? One is every battery should be, for every cell chemistry, there are certain windows where they are degrading less and where they really perform safely or perform safely. Thing is, it can change over time again. That's the tricky piece. That's the one thing. And the second thing is a lot of where there are some areas which can get safety critical. The thing is, and now connecting back what I have mentioned before, is when you look at this as energy storage asset, and then for example, SOC calculation is not proper, and then you have an imbalanced system. So some cells in the systems are at 85%, some are at 100%, for example. And then the control system has really hard work to balance those systems. And that can lead that certain cells get pushed over those limits. And that can get really safety critical. So even if the bands from the asset owners are put in the right manner so that it doesn't impact the batteries in the long run and it's less degrading, the imbalances of the systems can be still very safety critical, because the battery management system is not handling the imbalances, and then the control system pushes everything up, but you should not push one of the other modules and cells up because it's already at the limit. And then additionally, you have some sensor offsets and those kind of things, and this can be, of course, very safety critical. So this is actually where
the safety element. There's also this is probably an example of how my brain works. Yes, the safety issue is an issue, but to me, the thing that goes in my mind is there's opportunity that's left on the table here, which is, you may be using the lowest common denominator, if you like, as the measurement. And you may be saying you've got 85% charge in your battery system, and actually only 1 of 1,000 is 85, and the rest are at 100, and you're still clipping it at 85. And then all that bit on top is money left on the table.
100%. And I think that's exactly playing into what you have mentioned at the beginning, right? This ROI improvement. So there's a very technical component to it, but at the end of the results, you can squeeze more out of your energy storage assets when your SOC is, for example, calculated the right way, right? Because otherwise you always have to build additional safety levers on top of it. You can't get as close to the barriers and boundaries as you like to. And this is actually what we do in the operational phase, helping those asset owners to understand that by, for example, more advanced SOC calculation. And they can see also upfront if their SOC calculation is off, for example, and then I can adjust it accordingly.
The analog I'm thinking of here is a bit like if you go and buy a car and you can remap it. Some cars, there's a lot of Japanese cars, for example, where you can remap the engine, you can get a few horsepower out of it. And basically you can do it within the warranty, you can get away with it. And then there's other cars where you can't do it. I mean, if you go and buy a Caterham track car, you can get another 30, 40 horsepower out of it and stay within the warranty by remapping it. And my question is, so I'm a bit of a car nerd. My question, is it the same with battery cells? So can you go to LG and LG say, if you use TWAICE and you want to eke out a bit more value, then that's okay. But if you go to a different provider, say CATL or BYD, they say, no, our numbers are the right numbers. If you go outside of this, you're outside your warranty. Because there's some conflicting forces here, technically and commercially. How does that all fit together?
Yeah, so it's a very reasonable question. So at the end, it's how is the market set up currently? You have this large dominant cell manufacturers, LG, CATL, Samsung, Panasonic, SK, and so on. But it's not too many out there. And a small portion have a very large market share. And you're 100% right. They give certain warranties on their battery cell and ship it. And most of like the energy storage companies, they just have to live with it, right? And as soon as they go out of like their windows, which the cell manufacturers say they should operate them, they will lose warranties or void warranties, or also there are concepts of penalty cycles. So you get like specific amount of cycles per battery. And when you like, for example, overcharge over like too high temperatures, then they get penalty cycles. So the number of cycles get reduced over time. So they're very interesting concepts in the market. But at the end, you currently either you take own risk, the cell manufacturers doesn't take an additional risk. The interesting piece here is that it's even not often required to get out of like the specification of the cell manufacturers, because there is already so much optimization possible within those windows, which are not used currently. So I think that's like one is really like the pressure on the cell manufacturers. I think they are just too dominant and they are too much into scale. They don't care about it. They ship it and take it or leave it. And then the asset owner integrators have to live with it. But there is already like a lot of like optimization potential within those windows. And then there are like additional concepts. So for example, what we have launched a couple of years back with Munich Re together. So to provide additionally like longer performance guarantees for batteries by really like the monitoring piece, but also on the other hand, having an additional partner which can take some risk like insurance companies.
I was going to ask you about that. So what about insurance companies? What's the relationship? I'd imagine that there is a massive opportunity for asset owners and also for your business in working with insurance companies to use this data in a more in a commercially reliable way. So how does that work? How are you thinking about the relationships between insurance companies and data and what you guys do?
Yeah, so in general, there are like plenty of opportunities on like data insights, battery analytics, and linking it to any form of de-risking. And insurance is more or less de-risking it, so it's the same value proposition. So we're working on that for quite a while to really like provide additional value to like the asset owners or integrators. And there are more or less currently two major use cases. One is really like what I just mentioned, this performance guarantees. So like an integrator, for example, not only wants to like, they get 8 years of warranty from the cell manufacturer, but they can't win the deals because they have to provide 10, 15 years. So they try to push the boundaries and provide like 12 years of performance guarantees, but that creates, of course, additional liability for them. And this must be de-risked through insurance companies. They don't understand if this additional like lifetime is even possible. So they need to have an insight of like battery analytics and predicting lifetime. And that is what we do together with Munich Re currently as well. And the second use case is a completely different one, but also linked to insurance. It's really like fire insurance or like property damage insurance. So like when you like insure your assets, property damage and fire insurance, then of course helping like as an additional safety layer if those storages are like behaving or performing correctly, and helps insurance companies to get more comfortable with taking more risk on energy storage assets. And it's a great thing, right? Because when we really work together like this, then it also helps to unlock that more money is flowing into the ecosystem and more money is flowing into energy storage assets. Because I think that is what we all together need to achieve, right? To get the big money into assets. And the big money is usually where they are like the risk averse ones. So we need to maybe make sure to de-risk it so that the really like the big monies can flow into energy storage assets.
When I'm hearing you talk about the company and what you guys are doing, my mind can't help but thinking about product stuff. Think about product stuff a lot. And so a lot of what you build is quite similar to what we build. So it's data feeds, it's lots of data cleaning, it's some analytics tools on tops, it's lots of visualizations. But then the thing that you guys have to do, which is a bit different to us, is you have to make judgment calls about lots of different data sets, which we don't do. We don't do judgment calls. You guys do judgment calls. And why I think I want to just ask you about that is I would expect that you have to walk a thin line. By the way, we've gone completely off all of the bullet points I sent you that we're going to talk about, but hopefully that's cool. We can edit it out if you want to. But so my thinking is, I'd imagine you have to walk this thin line. There's like a pragmatic line, because if you're doing alarms and notifications, for example, for customers,
Yes.
if you're doing alarms and notifications, for example, for customers, the last thing you want to do is bombard your customers with loads of alarms, to the point where the problem with alarms in technology, right? If you have too many alarms, people just ignore them or they turn them off. And you also don't want to be this Cassandra or, town crier software solution, which is constantly telling you everything's going wrong, the future's bad, you need to spend money, you need to maintain, you need to do this, you need to do that. But on the other hand, it's also your responsibility and your whole brand as a company to get that right, and to make sure that your customers are informed operators, and that you notice things with software before they could notice things themselves. So how do you think about, as a company level and as a it's a bit of a deep conversations, but as a company and as a product builder, how do you think about getting that balance right?
Yeah. So that's a very good question, and a lot of product related topics in here. So I think what our USP is that we are 130 people, and I think we are like a 70, 80 battery engineers, software, product people. And I think what we put on the table is domain expertise. Let's call it like this. And I think it's our duty to transfer this domain expertise to our customers. And because coming back, we have mentioned before, where do you operate your batteries safely, or that they are not degrading slower? That is what we can answer, and we need to transfer that to our customers. The thing is how we do that, and we invested heavily into to provide that a bit at scale. So really, you have the data feed in, and then you have this analytic platform or analytics factory, which then really translate into actionable insights, notification alerts, but also recommendations. And that is coupled with a very strong customer success team, which also contains battery engineers and data scientists, which really partner up with the customer, because you have to fine tune the notification, the alerting. You really the customer also needs to get trust into the systems, right? When get I notified, when not. So I think it's a very strong collaboration, but also I think one key is really investing heavily into providing those actionable insights at scale, because otherwise we can't go forward and support the industry when they are really ramping up, and they do currently one storage after the other. So that's also a critical piece. And the third thing is, you're right, I think we need to stay the domain experts. That's part of our business model. So when you look at in Munich next door, we have, for example, a large battery research center laboratory, where we also invested heavily into capabilities to advance our domain expertise, our analytics capabilities. For example, when you look at future cell chemistries, we have already several of next generation cell chemistries in our laboratory, to understand where they operate the best way, where not, where are they safe, where not. And I think that is also one part of our business, to understand that domain expertise, make the judgment call, embedded in actionable insights, and deliver it to our customers. But it's not easy. It's not easy.
Yeah, I bet. I want to ask you some cheeky questions now. So you guys have got a lot of data from a lot of different asset types, stationary assets, EVs, all sorts. So you have this kind of macro view of lots of different types of assets that are operational or commissioning or whatever. Do you have some quick wins? So for our listeners who might be thinking about specifying sites, or specifying assets, or commissioning them, or operating them, of course, you could plug your software and say you need to have the best software and you need to be doing battery analytics. But separate to that, what are some quick wins that people can make?
So that's a very interesting question. So, the typical answer is always with batteries, there are not too many quick wins. So, because there is so much differentiation of cell chemistry, cell provider, asset owners, different operating modes. So the thing is that there's so much technical complexity in this asset, which is so different to, for example, wind and solar. Maybe it has been in the past, but so it's tough to answer. I think, at the end, when you go one step back, it also highly depends on, for example, cell chemistries of those assets, right? And when you look at the current trend to LFP batteries, everyone, the whole, or like a lot of people in the industry think, I mean, LFP batteries, and now they're safe, and that's a sure bet. But even that, it's not 100% right and true, right? Because there's like a cell, LFP cell is not an LFP cell, right? It depends on the cell manufacturer, on the quality processes, and so on. So I think there is not a lot of quick wins. In my opinion, the really like crucial piece is, I think the commissioning phase is critical. So in terms of like money invest and outcome, this is like a phase where both parties really win. And it's also, when you go one step back, it's actually crazy. You invest like hundreds of millions in energy storage assets, and this handover period and this installation period is more like still, let's call it like in good words, a process for improvement, how the assets are checked there currently. So I think that is really like a good starting point, even if you don't like do in-life monitoring afterwards, but that's a good start, good thing
Well,
to
let's
start.
face it. By the time you're on site and you're doing commissioning checks, the whole program is at your month late, right? Loads of things have happened that you never expected. And then the whole project is squeezed at this point. In commissioning is like the hardest job because it's really important. And everyone from the program manager to the bank to, the whatever is squeezing your time frame. So you thought you had 3 weeks and you've actually got like 2 days. And it just always happens. And yeah, there's some work to be done here. Can I ask you about specifics of commissioning though? Because I'm always surprised by some of the commissioning tests which are relied upon, let's say. So take a step back for a second. If you're buying a 100 megawatt hour system and you want it to be able to go from full charge to 100% to 0 or 90% to 10, one would think that at commissioning you would do a full power step test at sustained full power to determine whether it can do that. But one thing that always surprises me is how few assets are actually commissioned that way. And a lot of them have got half power tests or quarter power tests, 25% or 50% over a longer period. And then you tick the box and say, yes, it's like one's a power test and one's an energy capacity test. And there seems to be a blurred line where OEMs and the folks who build these things, they definitely want to push you to the less stringent test. And there's usually a meeting in the middle. Yeah. What do you think asset owners should do there when they're being pushed by the system integrator or the OEM to do a less onerous test and time's running out and perhaps it wasn't defined in the contract up front properly or the specification properly? What tests should asset owners definitely do?
So you're absolutely right. I think like the commissioning phase it's an intense time for everyone involved there, because everyone is and everyone is really pressuring to get the storage live and earn money, and there is no time. I think due to that, it's also so crucial. I mean, we call it digital commissioning instead of physical commissioning, because there's like a lot of actually even time you can win, because you're right. There are a lot of those tests I mean, there are some companies, they switch it on and it's on and okay, then more or less it's accepted. So I think we're now in the next phase. And I think that is also what we will see the next 1, 2, 3 years from now, that all asset owners, they have learned. So when they buy storage assets, they have a way more granular specifications in their acceptance of the energy storage sites. I think there is not always the full tests needed in a lot of scenarios. The thing is, it also even depends where you like in which, for example, state of charge you're doing the testings. So there's like a lot more detail into it. What we do is we really work closely with the asset owners and even integrators to define also the tests per site together, because when they are like assets which are more into like very power driven applications, you should rather do more like power driven like testings. While on the other hand, there was like some storage sites which are really more on the energy shifting side, for example. The test can look different there. In the best scenario, you do both parts of the equation, but that's like a matter of like time and everything. So our goal and our domain expertise was sitting together again with the customer and also even define those tests and then draw the insights out of it. The good thing is, right, the data is there. It doesn't add additional time to the commissioning. It even reduces it often because they can act way faster. Imagine like this example I've given before, where you really identify if the modules are connected the right way. if you have to do it afterwards with a thermal camera and go through all the sites, and when you see them in Texas or in the US, like the hundreds of megawatt hours, it's a fun experience. So to draw that and service that up to the surface in a more optimized way is crucial in the commissioning phase. But I think it's like the maturity level of the industry right now. Everyone is moving more in that direction. It will get more digitalized. It will get more data driven. I think that's just like a natural process we will see currently.
Now I want to talk about the future. So where are you guys headed? What does the future look like for your business? You're expanding internationally. I can think of lots of different product add-ons that you could add on along the way. I'd be interested to know whether you're interested in, putting physical hardware on people's sites, or you're going to stay out of that, or whether, there's other things you're going to build. But what does the future of the company look like?
I mean, currently we really focus on the energy storage and like the EV market, and we do that in Europe and in the US market or North American market, because like both markets are really ramping up, and our core goal for next 1 to 3 years is really like supporting this ramp up period with de-risking it, increasing availabilities, really investing in our platform. We will not going forward put any hardware like on sites, because I think at the end, right, all those assets get more and more connected and data is flowing. As we found it in 2018, that was not the case, honestly speaking. So that was a good trend, so that really now the data is also available. I think what will turn out and what will also make us successful, and where we already have invested heavily in the past, is really building like an analytics platform. And what I mean with that is that we can really integrate with a lot of different stakeholders in the industry. So when you look, for example, all the trading companies out there, everyone would wish to have like proper and better SOC calculation for their assets or SOH, but it has to flow into their system. They have to easily integrate. So we are just one piece of the puzzle, but I think to lower the barrier to access those information from different parties in the ecosystem, that would be like one of the key advancements also like going forward the next 1, 2, 3 years. So that's one thing. And I think what we also did well in the past, and where we try to continue, is really building today we really talked a lot about monitoring and cloud-based analytics on energy storage assets. I think it also gets crucial to build a provider along the life cycle. So for example, when asset owners design assets or like an integrated design storage assets, to really also supporting them already with design decisions, because that can of course also unlock a lot of things. Because I think with energy storage assets, like the decisions you make the early in life or like during the design phase have a very strong impact on your profitability and business case going forward. So really also pushing more into that direction, helping them there as well through like lifetime simulations and other areas. So really being a provider along the life cycle will be another area we will expand to.
All right. Now to the two questions that everybody gets asked. The first one, this is your opportunity to plug. I do think you've done a bit of plugging throughout the episode, but if you've got something to plug, a big announcement or something you're working on, now is the chance. And then the second question is my favorite one, which is, what is your contrarian view? But first, the plug.
So first, the plug. So, I mean, at the end, we have like a lot of things to unplug going forward, right? I think it's really like for us, a lot of like things are happening, releasing on the availability side, on the safety side, on the health monitoring of energy storage assets. And I think one major crucial topic will be better SOC also, for example, traders, because that really helps them to unlock more of the energy storage business case. So that's the plug.
Okay. And now the contrarian view. So what do you, Stephan, believe that not everyone else believes?
So I'm not sure if not everyone, but I think, look, what I continuously face is that, I mean, we're a battery analytics company. We help them to de-risk it and like understand the assets better. And we're continuously faced if it's still needed, right? Because batteries are getting better and better all the time, right? And when you go one step back I think that's a bit of a misconception, because I always like explain it like you have like this spider graph, and with covering one area, and when you optimize in one direction, right, you pull it away from another functionality, cost, safety, lifetime, whatever. And I think when you look, for example, so that's one piece of it, right? So I think even if you optimize, get more safety or more energy density, doesn't always come with less cost, or when it comes with less cost, it doesn't mean that there's like better safety. And second thing is, this whole industry is ramping up so heavily now. So a lot of cells which will be deployed the next 2, 3, 4, 5 years from now actually are built on manufacturing lines which are not live yet.
Yeah,
And
yeah, the elephant in the room.
it's elephant in the room. So first of all, they have to be built. But on the
Yeah,
other hand, they also have to ramp up, and everyone knows the quality yields of those lines and how long it takes and how much effort it is to really have very proper high quality cells in the market then. And so we will see that, so that there will be still incidents in a couple of years from now, because it's just like a matter of like this ramp up, then the continuous improvement. And I third is also like when more newer cell chemistries are coming in, for example, now sodium ion or others, they just add an additional layer of uncertainty because
yeah.
they are less used to in the market and so on. So really like this all together really, I would say, is that for me, the thing that a lot of people think batteries are just getting better and that's done. And I think it's just not true.
So last one on sodium ion, because this is a
Yes.
hot topic right now. Sodium ion, it's got the same buzz around it. It's kind of like hydrogen 3 years ago, where everyone was like, hydrogen's going to solve everything. We're going to put hydrogen everywhere. It's safe and it's clean and it's like this Swiss Army knife thing. And yeah, it turns out hydrogen ain't that. So sodium ion, are you really excited about sodium ion, or are you just really excited about it? That is the definition of a leading question, I think.
Yes, absolutely. It is.
Like, the disclaimer is I have no affiliation with any sodium ion companies.
Good. The good thing is about hydrogen in 2018, as we founded TWAICE, it was continuously conflicted with like, if it's not hydrogen, which will make it in all those applications. So we luckily like passed that stage. And now the next one is popping up, like sodium ion. I'm excited about it. Why? Because I think there is like a lot of benefits to it when it comes to costs, availability of resources. And third, and that is actually why I'm most excited, is you can more or less use existing production lines to build sodium ion batteries. So because I think a lot of like next cell chemistries will like disqualify when they are not can build on like the production lines where like currently billions and tens and hundreds of billions is flowing into, because they will not shift in 2 years from now, right? So you need to really find some cell chemistries which you can put on more or less more easily on existing production lines. So look, we like have already like in our laboratory first sodium ion batteries and do like measurements and really like testing them and figuring out how they are performing. And I think we will see them in some entry vehicles in China. It's already starting. The same happened with like LFP batteries from BYD years back. So it's a similar trend. And secondly, I mean, just northward, I think a week or so from now, announced sodium ion for energy storage assets, like larger pouch cells. So I think sodium ion has at least the potential to follow like LFP, same trend as LFP batteries. It will still take a couple of years, but I'm very excited about this chemistry.
And how much cheaper is it?
Oh, it's so tough to say. I mean, at the end, it can probably get like 30-40% less in that ballpark, which is immense, right, in this industry.
It's absolutely wild, isn't it?
Yeah. So can you go from 100 euros per kilowatt hours to maybe 60? So that's the curve you can get to, but it comes with a lot of drawbacks. And I think so far, first of all, yeah, they need to overcome these drawbacks. And in the meantime, we will see some other interesting areas like LMFP, for example, like some kind of version of LFP will first enter the market and then maybe like afterwards.
What's that acronym? LMFP. What does that mean?
LMFP is like lithium manganese iron phosphate. So it's like
Okay.
you add manganese to the cathode. So it has actually can help to have really like a high energy density, but with the same costs more or less. So we see now more and more applications with LMFP batteries. So I think that is also like another trend which comes up. It's LFP, but it's LMFP.
Yeah. I feel so grateful to be in this industry. It is just so cool that we get to do this. All right, I want to say a massive thank you, Stephan, for coming on the podcast. That was a blast. Looking forward to seeing you sometime in the US when you're next over here. If you're listening to this and you want to find out more about TWAICE, we'll put some links in the show notes and you can get onto Stephan and the team. And until next time, I want to say thank you and see you soon.
It was absolutely a pleasure. Thank you.